Recording in progress. See the question. Last week, we learned about optimizations. Okay, optimizations and relative risks are all words problem in calculus. They are different. Optimizations is same as what you learned in pre-calculus, but you know, in pre-calculus, you do the calculate way, but in calculus, optimization, you will use the derivative to find the extrema so that you can find your minimum or maximum. For relative rates, we see the examples here. This is questions in the real AP test, free response part, okay? Let's see the first one. Okay, let me call student. Claire, please go ahead, read the question.
Okay, a paper cup, which is in the shape of a right circular cone, is 16 centimeters deep and has a radius of 4 centimeters. Water is poured into the cup at a constant rate of 2 centimeters cubed per second.
Okay. Now, we were given a geometry shape again, and this is the cone. So we will draw this guy. The radius is 4. This is a 16 centimeter deep. This is a 4 centimeter. The water is poured into a cup at a constant rate of this, okay? So we were told that the water was poured into here at this rate. So the volume change, the rate of the volume is dV over dt. dV over dt equals to 2 centimeter cube per second. This is given condition. What else do we have? We have here as radius of 4. We have here 16 as a height. We only know the rate of volume change here. And they ask question A, when the depth equals to 5. So when the H equals to 5 means the water leaking out, and this height, water go here, equals to 5. They ask you, what is the rate of change of the height? So they ask you dH over dt, okay? dH over dt. What do we do over here? Same like we do for the optimization question. This is the volume. And we have this similarity triangles. If you draw this right triangle, if you draw another right triangle here, so clear. Let's write down the triangle similarity proportion. H over R should equals?
H over R should equal 16 over 4.
Okay. H divided by R. This height over this radius should equals this height over this radius, which equals to 4, correct?
Mm-hmm.
And they ask us the rate of change of the height. So they ask the dH over dt, which means we want to replace the radius. So R is how much?
R would be 1/4 H.
That's right. R will be 1/4 times H, okay? So this volume is here, and we can plug in. We can plug in this guy, right? Okay, let's go ahead, plug in. R squared.
1/3 pi times 1/16 H times H.
So this equals
that would equal be 1/3 times 1/16, which is 1/48 pi h cubed.
Okay. Now, we were given dv over dt. We want to find the rate of change of the height. This is dh over dt. So let's do this, okay? We want to do the derivative. We want to do the derivative for your left and for your right relative to the time. So on the left, dv over dt equals to who?
What do you mean by on the left?
So this piece, you can do v as a dependent variable, okay? V as the dependent variable, but t as an independent variable. So you do the derivative on the left, which is dv over dt, correct? You do the derivative for both sides. Yes?
Oh, okay.
Okay. So the left becomes to dv over dt. And then on the right, it becomes to who?
1/48 pi times 3h squared.
And then dh over dt. Yeah, hold on. Let me show you over here. So you don't worry about this part, okay? Yeah. You see, if you just do dv over dh, this will equals 1/48 times pi times 3h squared, correct?
Mhm.
Yes, no problem, right?
Mhm.
Because h as the independent variable, h as the dependent variable. So this is your y, this is your x. So you have your dy over dx equals this. Now you put the dh on the other side, and then you do the d over dt on both sides. This is called relative rates, okay? We used to do y equals to fx, and then dy over dx is f prime of x. This is what we used to do, okay? So we used to say y equals to f of x, and then dy over dx. This is a derivative, f prime x, correct? Now, you need to consider a third variables. Previously, you only have y and x. Now you want to treat x as a function of t, y also as a function of t. So what you do? You do dy over dt equals to df of x over dt. Okay, that's what this means.
Okay.
So you do the same way as what you do the derivative. The only change is you do dv over dt equals this guy, do the chain rule and do the exponential, the power rule. So copy down this and then write down 3h squared. Okay,
Mhm.
that makes sense.
Yes.
So this equals,
So that would equal just 1/16 pi h squared times dh over dt.
okay. All right. Now dvo dt is how much?
dv
How
over
much? How much is dv over dt? Given. It is given.
It's just that, right?
This is dv over dt, right?
Mhm.
So that means 2 equals to 1/16 pi. H, here is h, right?
Uh-huh.
times h squared, which is 5 squared, and then dh over dt. There you go. Does that make sense?
Yes.
Yes, that's right. Now we can simplify to find the dh over dt, okay?
Okay.
So we can times 16, that is 32, and divide by 25 pi, right?
Oh, yes.
Okay, equals to dh over dt. Does this make sense?
Yes.
Okay, and when we do this question, we have to keep in mind, we need to provide the units. So we need to make sure when we write down the answer, the rate change of volume is this unit. dH over dt has this unit. Make sense?
Yeah.
Okay, now that's for the A. For the B, this time they don't tell you the depth, but they tell you the radius. And they ask you rate of change of the radius, not the height. Okay? So we want to, this time, we want our expression have R only, not H. So we will replace. So we do H equals how much?
4R.
Okay. Now we can replace. Okay. The old formula is this. And then H equals to 4R, right? Okay. Now let's go ahead, do the same way as the other question. Let's see, do the related rates for both sides, please.
Okay, so that'd be dv over dt equals 4 pi over 3 times 3r squared times dh over dt.
No, this is R only, so it's dr over dt, okay? Next, dv over dt is given. So we will plug in. This is 2 equals 4. This canceled, right?
Yeah.
How much is the R?
3 centimeters.
Let's plug in. R equals to 3. Okay, so dr over dt. This is 2 over 4 pi times 9. Yes. So dr over dt equals to 1 over 18 pi, correct? This has the same unit. Make sense now?
Yes.
Okay, now that's the relative rates question. This is the question number 1. Number 2. Cindy. Okay. So we will do the same way, okay?
Yeah.
Go ahead, read the question.
The snowball is in the shape of a sphere. Its volume is increasing at a constant rate of 10 inches cubed per minute. A, how fast is the radius increasing when the volume is 36 pi inch cubed?
Okay. So this is the sphere. What's the volume formula?
4 over 3 pi r cubed, maybe.
Okay. They give what? What's the given condition? Who is this guy?
Like the change in volume per minute.
So it is dV over dt, right?
Yes.
dV over dt equals to 10.
Mhm.
Now you can put the unit here.
Yeah.
Now we want to do this guy. We do the relative rates for both sides, okay? We
Mhm.
do this guy over dt. We do this guy over dt, okay? So the left becomes 2. dV over dt equals how much?
Equals to 2r squared.
If you feel confused about doing the relative rates, we can see first. If we do dV over dr, yes? dV over dr is who? Correct. Right. This equals 4 pi r squared, right?
Yeah.
So dV equals to this. Make sense?
Yeah.
And then we do one more step. We can do the relative rates on both sides. Then dV over dt is going to be 4 pi r squared dr over dt, correct? See, both sides divided by dt.
Yeah.
This is the same. If you cannot do this in one step, you do this first to make yourself feel clear. You do the relative, you do the derivative, you get here. And then you do divided by dt for both sides. So you got dv over dt equals to this guy times dr over dt, okay? Make sure your v and r looks different, otherwise you will be confused. Read this guy here.
How fast is the radius increasing when the volume is 36 pi inch cubed?
Okay, so we want to get this value, and we know this value. As long as we can know the r, we can get here. But this is not the r, so what can we do?
That's the volume. So you can
Solve it, right? What's
so
the
when
equation? What's the equation?
So when the volume is 36 pi,
Continue,
it's also
please.
equal to 4 over 3 pi r cubed.
So 4 and 4 on both sides, it can cancel, right? And the pi canceled. This equals how much?
Equal to 9.
27.
Oh yeah.
So r equals
3.
That's good. We have no problem to solve the dr over dt, right? Go ahead, please.
Okay, so dr over dt is equal to,
we can plug in this guy on one side. This is dv over dt, right? So 10 equals
is equal to 36
pi. Oh, okay. 3 squared times dr over dt. Yes. So dr correct.
Yes.
Now the second part. Second part is a little bit tricky.
Mhm.
Please read the question.
How fast is the surface area increasing when the volume is 36 pi inch cubed? So surface area is 4 pi r squared.
That's right.
Yeah.
Next.
And then, okay, so it's asking how fast is the surface area. So it's ds over dt. And then, so that's 4 pi 2r is equal to 4 pi 2r times, yeah.
Next.
So that's just 8 pi r times dr dt. And then you already know what dr over dt is.
Yeah, this question is nice because this two has the same volume. That means we are able to use this guy directly. Okay.
Yeah.
If they change the question a little bit over here, then we have to recalculate the dr over dt and then plug in, right? We are lucky that this question they make these two numbers the same so that we know the dr over dt already here, okay?
Yeah.
If this is not same number, we have to recalculate, okay? There get canceled. How much?
So that's
20 over 3.
Yeah.
What is the unit here?
Inches squared per minute over minutes.
All right, very good. Number 3. Lawrence. This question is a little bit hard, okay?
Okay.
And let's see here.
Do I start reading?
Yeah, go ahead, please.
The balloon shown is in the shape of a cylinder with the hemispherical ends of the same radius as that of the cylinder. The balloon is being inflated at the rate of 261 pi centimeter cube per minute at the instant that the radius of the cylinder is 3 centimeters. The volume of the balloon is 144 pi centimeters cubed, and the radius of the cylinder is increasing at the rate of 2 centimeters per minute. And at this instant, what is the height of the cylinder?
Yeah, how do you feel about this question? Very long, right?
It is very lengthy.
It's very lengthy. So let's see the way to work on the words problem for calculus questions, okay? We read one sentence, we start to write down something, okay? First one, I know this is a cylinder, okay? This is a hemisphere on both sides. Radius here are the same, okay? So based on the first, we will be able to write down the total volume, right?
Right.
So what's the volume?
Isn't it pi r squared times height first for the cylinder?
So the cylinder part is pi r squared.
Pi r squared, right, and times height.
And then this top is a semi sphere. This is another. These two
Mm.
together is a what?
It's a full one, so it'll be 4/3 pi r cubed.
Yes.
Okay.
So this is what we read for the first sentence right here. Okay, now we finish here. Second sentence. The balloon is being inflated at the rate of this. What's this guy?
That would be, was it dv over dt?
Very good. dv over dt equals?
261 pi. And then do we have to write centimeter cubed, or you don't have to?
Yeah, we can keep the units.
Keep the units? Okay.
Yeah, so we are finished for here. Next.
At the instance, the radius of the cylinder is 3 centimeters. So we
Okay.
can
R equals to 3, correct?
r equals 3. Okay.
R equals to 3. Next sentence.
And the volume of the balloon is 144 pi cm cubed.
So the volume.
Mhm.
So volume is
144 pi centimeter cubed.
next.
The radius of the cylinder is increasing at the rate of 2 centimeters per minute. So is it dv over dt? Or sorry, dr. Sorry, dr. I don't know why I said these.
dr over dt equals?
It's just equals 2. And then centimeters per minute. Yeah.
Okay. So this is the correct way of working on words problem. You read, you see the graph, you start to write down. You read the next sentence, you write down. You do the translation. You do the translation after you finish reading every single conditions. And then we look at the question, okay?
Okay.
Now question, read please.
At this instant, what is the height of the cylinder? So we need to find 8.
Given this, they ask you the height. They ask you the h, correct?
Right.
Okay. So, well, we have the volume.
We have the volume, right?
We have the R.
We have the R, right?
We should be able to get the H, do we?
Yeah. We have
Now,
one known.
Let's go. Sure. So we are solving one variable equation, which is algebra 1.
Yeah.
Let's go ahead.
Okay, so we can plug everything in first.
Sure.
144 pi, which is the volume, equals pi and then times 9. Is it? 9 pi, or pi 9, yeah. And we don't know h. And then plus 4/3 pi, and then we know that was 27.
Okay.
And then we can cut some stuff out. We can cut down the 3 and then the 27. That would be 9. Just 9 left.
Okay.
And then we can rewrite this as 9 pi h plus 36 pi.
Yeah, we can leave this guy there. We can move this to the other side, right?
Right. Oh yeah, we can definitely do that.
Okay.
And then everything has pi in it, so I think we can cut that as well.
Sure.
And then we can solve 144 minus 36, which is 108, I think. 108 to 9h. Okay. And h, and then h is going to equal to 12.
There you go.
7 centimeters. Okay.
Yeah. This is also, you see the year, this is the AP response, free response questions in 1985. Okay, long time ago, many years ago. And all of you haven't been born yet, okay? All right, so Even though the question looks complicated, but actually it is not, this is the algebra 1 question, okay?
Okay.
Second one,
How fast, okay, at this instant, how fast is the height of the cylinder increasing?
so what this guy is asking,
So it's asking for the dH over the dt.
okay, it's asking dH over dt. Here is the tricky part, okay? We have to pay attention for this one because this guy is not nice, okay?
Okay.
It's just like you are playing the video game, okay? You want to show your friends how well you can play that game.
Right.
Okay. Now here, you want to get a dH over dt.
Right.
But the problem is, the previous example we show, we just have one variable. We have no problem to change this guy to dv over dt equals something times dr over dt. One variable.
Yeah, we can use derivative.
Everything we do so far is one variable. This time is the first time we see two variables. Not only r, you also have a h. Your h and r are changing at the same time.
Oh,
So yes, this is the first time we see this, okay? So we want to pay attention to here. You have r and you have the h. And in this graph, there is no proportion you can write down as h equals to somebody of r. You don't have that function. You don't have r equals the function of h either. So what can we do? This is a tricky part. So every student, please focus on what we are doing now, okay? This is critically important. You still do dv over dt, okay? You still do dv over dt.
okay.
So, I don't know if any of you are going to learn multivariable calculus in high school. If you are going to learn multivariables, and you have to know about this, okay? Yeah. dv over dt.
Okay.
This guy is easy to take care. It only have r.
It only has
This
R.
guy, you have to apply the product rule. This guy, you have to apply the product rule. So you do dv. I'm going to erase this and we can do it together, okay?
Okay. Should we take out pi first though?
Yes, we can take out the pi. We can let the pi put on the front, okay?
Okay.
So we can do pi. And then look at here. This guy is a product. If you don't want to do this guy derivative, what you do is you do r squared.
Okay.
You copy down r squared. dh over dt, correct?
dt. Okay.
Right. dh over dt. Plus.
Right. And then it'll be 2r.
Yes.
2r. And then we gotta do the r, dr over dt.
There you go.
Okay.
Times.
And then times h.
There you go. Very good. Plus, the pi was taken in front. We can just.
So just be 4r squared.
4, 3 times 3 r squared. And then?
And then times,
dr.
And dr over dt, sorry.
There you go.
Okay.
Make sense?
Yeah, it makes sense.
Everybody, I pause here. If you have any question, please ask me question now, okay? So this is the product. This is the product, okay?
Okay.
No question? Nobody have question? Now we are going to plug in.
Okay.
Okay. who is the dv over dt?
And we already written it down, 261 pi, and
Okay. And then we do pi
pi
times
times
r
r
squared
squared 9.
mhm,
We can just,
dh over dt, right?
and yeah, and we don't know that yet.
Plus
Plus 2 times, so that'll be 6.
2 times 3 is 6.
Yeah,
How much
And,
is dr over dt?
it's just 2 centimeters per minute.
Okay, 2
You know?
plus,
Okay.
Mm.
Okay.
this is a 4
4. Wait,
times,
did we forget h? Like 2r dr over dt times h.
oh yes, yes, 2 times h. So h is 12, right?
H is 12, right?
Mm,
We already
okay.
solved it right there.
2 times r is 6,
Mhm,
dr over dt is 2,
mhm.
h is 12.
Oh yeah, we can write 12. Yeah.
Okay, so plus 4
Mhm,
r squared, r
And then
is
9.
mhm,
Mhm,
dr over dt equals
2.
2. There we go. And we can cancel the pi, okay?
Yeah.
So we can cancel the pi.
Mhm.
Okay, so let pi be gone. This is
Okay.
9 times dh over dt.
Mhm.
This is 12 times 12, which is 144.
44.
And then plus 72, right?
22. Right.
Okay. Now let's continue. All the pi get canceled. So we can get dh over dt. So let's see. There's some number sense, okay, we can do to make this calculation faster, okay? Look at
Okay.
here. 2 plus 6 plus 1 is 9. This
Yeah,
number divisible by 9. This divisible by 9, this divisible by 9, this divisible by 9. Let's divide it by 9 for each term.
Okay.
This guy divided by 9, how much?
That would be 20 something. I don't know. Oh, let me.
9.
29. Okay.
Correct.
Okay. Yeah. Oh yeah, correct. Yeah, that's right. dh over dt. We get rid of that one. And then plus 14 or no, I have no idea. Is 16?
Good.
16, okay. 16 plus, and that'll be 8 plus 8.
There you go. So 29 minus 24.
24. Mm-hmm. dh over dt, when that equals just 5.
Okay, yeah.
Okay.
For the free response question, you need to keep your unit. Okay, you need to
Right.
keep your
Okay.
so
Mhm.
you write down this.
M over min. Min.
Mm.
Yeah.
There you go. That's it.
Okay.
Okay. So if we don't do this way by writing down every sentence, you feel lost here. Okay, and you feel like this question is really hard. Not really. This is algebra 1. This is algebra 1.
Mhm.
This part is the only places that involve with calculus. This is the only step involved with calculus. Everything else is algebra 1, even elementary school, right?
Right.
Okay, all right. So after practice, we will not have trouble for this kind of question. Very good. You can take a rest. I'll call next student. Very good. Joy.
Yes.
Let's do number 4.
Okay, the
So
figure,
let's go ahead.
the figure shown represents an observer at point A watching balloon B as it rises from point C. The balloon is rising at a constant rate of 3 meters per second and the observer is 100 meters from point C. A, find the rate of change in X at the instant when Y is 50. B, find the rate of change in the area of right triangle BCA at instant when Y is 50. C, find the rate of change of theta at the instant when Y is 50.
Okay, wow, this is 1988. Okay, all right. First, we see this figure. Okay, we see this figure, and then we start to analyze the sentence. This figure shows an observer at point A watching the
Yeah.
balloon. So this is a person. Here we can draw a small person. Okay, I don't draw it very well, not like many students here who can do really nice sketch. So this is a small person here. The balloon is on this position. So I'm going to draw a red balloon, okay? So the balloon is rising up. Now this balloon is keep rising up. This guy is watching the balloon. The balloon is rise at a constant rate of 3. What does this mean? It is a speed, right?
Yeah.
It is a speed. It has a speed, meter per second. That means your dy over dt equals to 3.
Okay.
Doing calculus, optimization question, or relative rates question, the key point is if you can be a good translator to translate this into this. If you can translate correct, no problem. But if you cannot do the translation, you cannot solve the problem. So we translate over here. The observer is 100 meters. So that means this is 100, correct?
Yeah.
Now we finished all the conditions. That's a right triangle. What we can write between these 3.
Yeah, so like with all 3 of the questions, they have like y at 50, and then since it's the right triangle, you can use the Pythagorean theorem to find what x is, right?
Very good. Tell me the Pythagorean theorem here.
Okay, so I like took off a 0 at the end of 105 and 150 just to make it easier. So I have like 10 squared plus 5 squared, and then that's 100 plus 20.
Hold on. We cannot suppose this y equals to 50. Y is a variable. We don't.
Can?
Not yet. We want to treat this guy as a variable because this is dy over dt. This is something change. This guy is changing. It's not a fixed value. We don't replace this by 50 now. Not yet.
Okay.
Not yet. So we want to write down
100 squared plus y squared equals x squared.
There you go. There you go.
Okay.
Sometimes you do this guy square plus that square equals that square, but not now. We hold this. Okay. We will get this first. When we get here, we will be able to do the relative rates. Let's see. Everybody is relative to the time. So we do this guy derivative. Constant derivative is who?
Isn't that just 0? Yeah.
Y squared derivative related to time.
So yeah, that's 2y, and then
Yes.
Yeah.
Equals. equals how much?
Wait.
2x dx over dt,
Oh, okay.
correct?
You just did the derivative of x squared. Yeah.
Yes.
Okay.
You treat this guy as a composite function. You do the chain rule. This guy
Okay.
derivative do 2y. And then y derivative will be dy over dt. Chain rule 2x. And then dx over dt. Make sense?
Yeah.
Okay. Now you have the dy over dt given, right?
Mm-hmm.
So you want to get the dx over dt. So 2 and 2 canceled, right?
Yeah.
2
And
and 2
then
cancel. So dx over dt, dx
so
over
you would
dt
plug in.
equals to, you divide it by
2y.
x on both sides, yes?
Oh, okay. Yeah.
Make sense? Dx over dt equals to y over x times dy over dt, right?
Okay.
Now, dy over dt is how much?
3.
3. How much is y? 50, right?
Mm-hmm.
Y, because here, look. This is from everything here and the graph. Question A, find the rate of change in x when y equals to 50. So 50 is here.
Yeah.
3 is here. Now you want to get your x. This is the time as what you mentioned just now. You find out 100 square plus 50 square equals to x squared. You can find the x value and then plug in over here. This is the time to use this 50. Does this
Okay.
make sense? Okay.
Yeah. Yeah.
So x squared will be, I take a 50 square out. That's 100 over 50 is 2. So this is 2 square plus 1. I don't know if you are okay with this step. I take a 50 square out. This is 50 times 2 square, right?
Yeah.
Yes.
Mm-hmm.
So x squared equals to this.
Okay.
X equals,
So that's just like 50 squared times 5.
50 times square root 5.
Okay.
Now you can plug in. Now you can plug in, okay? So dx over dt is equals,
So
y equals to
50 and then divided by the 50 square root 5
Mhm.
and then times 3.
There you go. Does this make sense now?
Yeah.
Okay. Let's see next one. For the B, they ask you the rate of change of that area. Hold on, sorry, my Apple Pencil got lost. All right, it's back. So it's asking for the area change. How do we calculate this triangle area? What's the formula to do this guy?
Area is just 1/2 base times height, right?
Okay. I can treat this as a base, this as a height.
Yeah.
So I do 1/2 100y. Yes?
Yes.
This is 50y.
Yeah.
Correct. Right. So next, the ds over dt. ds over dt will be 50 times dy over dt, correct?
Mhm. Yeah.
And we already have the dy over dt, which is 3, right?
Yes.
So we plug in this guy as 3. So this is 150, correct?
Mm-hmm.
Right. Question A, as long as you can figure out the Pythagorean theorem and do the derivative on both sides and then plug in, no problem. Question B is a part of question which gives students for free as long as you get part A correct. So no problem for B. The tricky part is question C. They ask you change a theta. Oh, that's tricky. They ask you d theta over dt. How do we get d theta over dt? You see here, theta. This is y. But we know tangent theta is who?
So that's y over 100.
Y over 100. Very good. Tangent theta is y over 100. So we are going to do the derivative on both sides using the chain rule, okay? Tell me this time, what's the derivative for this?
So the derivative of like tan is just secant 2x.
And square, secant square.
Oh, secant square. Okay.
And then d theta over dt, right?
Yeah.
Equals
And
on the
then
right.
derivative of that.
1 over 100 is a constant. You put it in front.
Okay.
dy over dt, right?
Yeah.
Dy over dt. Dy over dt is given, yes?
Yeah.
But we want to, yeah. But the problem is we want to find out this, yes?
Yeah.
Yeah, we want to find out this. Let's see here. Tangent theta. We have a we have the trigonometry identity. This equals how much?
Secant square.
There you go. How much is tangent theta here?
Y
Well,
over
y, yeah.
100. Oh, 50. Yeah.
Right.
So 50 over 100.
Tangent theta equals to 50 over 100, which is
Which is just 1/2. Yeah.
So this guy is 1/2 square, which is 1 over 4, right?
Oh, yeah. Okay.
Plus 1 equals to 5 over 4, right?
Mm-hmm.
There you go. We solved the problem. Does this make sense now?
Oh.
Tangent theta equals 1/2. Secant square theta equals to 5 over 4, right?
Yeah.
Right. So d theta over dt will be this guy divided by secant square theta. Secant square theta is 5 over 4. Divided by 5 over 4 is times 4 over 5, correct?
Yeah.
And dy over dt is 3.
Mm-hmm.
So we can do this, okay?
Okay. Yeah.
There you go. And the units has to keep it. It's radian per second, okay?
Okay.
Yeah, this is a high level question. This is a high level question. Anytime they involved relative rates words problem with trigonometry and inverse trigonometry is high level question, okay? All right. Now we jump to the time of year 1994. They fly very fast. Okay, you see the year keep pushing forward. Olivia. Go ahead, read the question, please.
Okay, a circle is described in a square as shown in the figure. The circumference of a circle is increasing at a constant rate of 6 inches per second. As the circle expands, the square expands to maintain the condition of tangents. A, find the rate at which the perimeter of the square is increasing. B, at the instant when the area of the circle is 25 pi inches squared, find the rate of increase in the area enclosed between the circle and the square.
How do you feel about this question? Very long? Okay, so we start reading. This circle inscribed in a square. If you see a circle inscribed into a polygon, it is saying this is tangent to each other, okay? This is tangent. The circumference of the circle increasing at a rate of 6. If I use C to represent the circumference of the circle, this will be dc over dt, correct?
Yes.
Okay, so this is dc over dt. Next, as the circle expands, the square expands. So they tell you they keep being tangent to each other, okay? So if this circle push outward, the square is also pushed outward and they're still touching each other. Find the rate where the parameter of the square is increasing. They ask you, they give you the dc over dt, and they ask you this guy over dt, correct?
Yeah.
Okay, now let's pay attention to here. The circumference of a circle is by what?
2 pi r.
C is 2 pi r, correct? Let's write the relative rates on both sides, please.
So it's 2 pi.
We do dc over dt
equals 2 pi times dr over dt.
There you go. dc over dt is 6. Let's solve for dr over dt. 6 equals to 2 pi. So dr over dt equals?
6 over 2 pi is 3 over pi.
There you go. Okay. Now, based on the radius here to be r, how do we get the parameter of this square?
It would be 2r times 4.
Very good. Equals?
Is 8r.
So dp over dt equals?
8 times dr over dt.
That's right. Equals? We have here, we can plug in, okay?
Oh. So
That
it
makes,
so 24 over pi.
there you go. Very good. That's then question 8. Question is not hard, just passing those coefficients and we can get here, okay? Yeah. The second one is a little bit tricky. Let's see over here. Go ahead, read question B, please.
At the instant when the area of the circle is 25 pi inches squared, find the rate of increase in the area enclosed between the circle and the square.
Oh, so at the instant when the area of the circle is 25 pi. So the area of the circle is how much?
Pi r squared.
Equals to pi r squared equals to 25 pi, right? So r equals?
R equals 5.
R equals to 5. Now we want to get the area between, right? So what's the area between? How do we calculate the area between them?
You have to subtract the area of the square.
So this is R, this is R. So this is 2R on both sides, right?
Yeah.
So what's the square area?
4r squared.
That's right. What is the circle area?
Pi r.
So they are asking this area, right?
Yeah.
Okay, so we can take the coefficient out and write down this, correct?
Yeah.
And then we do dA over dt. If we do dA over dt, we want to take this out, yes?
Yeah.
Now let's go ahead.
So 4 minus pi times 2r times dr over dt.
There you go. Do we know the dr over dt?
Yeah.
The dr over dt is calculated from here, yes?
Yeah.
So we know the dr over dt. And how much is the r? We already calculated, yes?
Yeah.
Right, so we can plug in, right?
Yeah, so it would minus pi times 10 times 3 pi.
3 over pi. There you go. That's the answer. Okay, makes sense now?
Yeah.
Yeah, you see, in 1994, I don't think this question is harder. I think this one might be a little bit tricky. Okay. Number 6. Number 6 is even more complicated. Okay, this is 1995. 1995. So see here. Zhao Yuchen. Can you please read the question?
As shown in the figure, water is flowing from a small tank with height 12 feet and diameter 8 feet into a water tank.
You can just see a cylinder tank.
Cylinder tank that has a base with area 400 pi feet square. Takes each in feet of the water in the container tank is charging at the rate of h minus 12 feet per minute. Write an explanation for the volume of water in the container tank as a function of h.
Okay, that's fine. Yeah, let's see here. The question, first sentence, this is a figure. This is the conical tank. This conical tank has 12 feet height, 8 meter diameter. So the radius is 4. This is 12. Okay, so we are done for this 2. into a cylinder tank. This is a cylinder tank. Area 400 pi. If this is 400 pi, then the radius will be 20. Okay? If the base is 400 pi, this is pi r squared. So r will be 20. Now, so far, we finished the top. And the next, the depth h, of the water in the conical tank is changing at a rate of h minus 12. This part is really confusing. H is the height, and this is saying feet per minute. What does this mean? So we want to do the translation. Students, pay attention to here. This is a place, this is the key for this question. If you don't understand this, translate this correct. There is no solution for this question. Depth is changing at the rate. That is saying dH over dt. Your depth change rate, h minus 12. So dH over dt equals to h minus 12. Okay? This translates to this equation. This is the key to solve this one. Now, A. Write the expression for the volume of the water in this conical tank as a function of h. Now look at here. As the first question at the very beginning of the class, there, you have a cone. You can write the proportion. So triangle similarity, you have h over 12, h over 12 equals to r over 4. You have this equation. Then you have 12r equals to 4h. So r is h over 3, correct? Yeah, so you have r equals to h over 3. Now you have the volume. Volume is this. Yes?
Yeah.
Now r equals to h over 3. So you can plug in, right? You plug in this guy over here. So you got here. No problem, right? So your volume is expressed as this, correct? Now we are going to use the relative rates, our old friend, okay? Now let's go ahead.
1/27 pi
Times
times 3 h
square
to and the time
dH.
over dt
There you go. Equals
pi over 9 h equal to time dh over dt.
There you go. So far so good. Okay, so now dH over dt is this, right?
Yeah.
Can we plug in? We can plug in, right?
Yeah.
Okay. So let's plug in, okay? Use this guy. Replace this guy, right?
Pi over 9 times h minus 12.
Yes.
Uh-huh.
Okay. Now, who is H? H is 3, right?
Mm-hmm.
Let's plug in. Let's get it. H equals 3, so
So pi times
3 squared, right?
mm-hmm. Times 12 equals -9 pi.
Negative 9 pi. What is a unit?
Feet cube.
Hmm?
Cube.
Feet
Feet. Mm-hmm.
cube per
Minutes.
minute. What's the reason this equals to a negative?
The -12 here.
What does positive mean? What does negative mean? Okay, let's say this way, okay? If a person, if you graduated from college and you find a very good job and you are a penny pincher, okay? And you don't want to spend any single money. You keep earning money. So your income, your net income is positive, right?
Mm-hmm.
But if you are the opposite person, you graduate from college, but you don't want to look for a job, and you still have the habit of eating outside very often and have boba tea every day. So you have a negative income, right? Means
Mm-hmm.
you don't have any income, but you spend a lot of money. So that is negative. Yes?
Yeah.
This guy, you have the water leaking out. You have the water leaking out. So you have a rate of negative. That makes sense?
Yeah.
That means you have no income, but you keep going out. So you have a negative. But this guy was not leaking out. This guy contribute to here. So for this guy, the volume is increasing. This volume is decreasing. Okay?
Mm-hmm.
So far, so good.
Mm-hmm.
That's for B. Now let's look for C. Go ahead, read this sentence, please.
That be the depth in feet of the water in the
Cylindrical.
tank at what rate is y changing when h equals 3?
Okay. I tell you, for that year, this gave a lot of people big trouble because for the question C, they get so confused. Most people figure out question A. Some people figure out B. Very few people figure out C. It is because they don't know what's the relationship between this guy and this guy. Yes, this guy, the volume change is a negative. That means somebody else gets the volume from this guy. Who gets the positive part? That guy. If this dV over dt is -9 pi, then this guy dV over dt will equals how much?
400?
No, 9 pi.
Oh.
The guy coming out here goes to here, right?
Mm-hmm.
So this 9 pi was contributed to this one. So this guy dV over dt equals to positive 9 pi. Make sense?
Mm-hmm.
So dV over dt is 9 pi for this guy, okay?
Mm.
Can we write down the volume to calculate this cylinder?
Yeah.
It's how much? Base times height, yes?
Mm-hmm.
So 400
Pi times dy over dt.
volume is 400 pi
Mm-hmm.
times h,
dy.
right?
Oh,
Times y, yes?
Mm-hmm.
So let's see here. Hold on. So we can do this volume calculation. Cylinder volume is calculated by 400 pi, which is the base times the height, yes? Times the, and then the change, the rate of change, dV cylinder over dt equals to this coefficient times dy over dt, right?
Mm-hmm.
Dy over dt. Who is this guy now?
9 pi.
Hey, don't write down negative.
Okay.
You are positive now. This is negative, right?
Mm-hmm.
Okay. So this is 9 pi equals 400 pi, correct?
Mm-hmm.
And then dy over dt should equals to 9 pi over 400 pi, right?
Mm-hmm.
There you go. So actually, the last question is not hard, just because students feel confused. How do I get the dV over dt for the cylinder? Yes. So here are those kids. Here are those working parents. Yeah. They spend a lot of their money for their kids because this is outgoing. This is the guy who received. So this has a negative rate. This has a positive rate. That makes sense?
Yes.
Okay. Okay, I'm going to teach one more example. This one over here. This is a rectangle. And they show you dz over dt is 1. And dx over dt is 3 times of dy over dt. And at the instant, when x is 4, y is 3, what is the value of dx over dt? Everybody give a try. I already show you my solutions. And based on what we have learned so far, go ahead, run this question. You want to apply the Poisson theorem and then run the relative rates. So what we do for this question, we write the z squared equals to x squared plus y squared. And then we go ahead and run the relative rates for both sides. 2z times dz over dt equals 2x times dx over dt plus 2y times dy over dt. And then 2 can be cancelled. Z times dz over dt. So when x is 4, y is 3. How much is z? Z equals to 5. So we can plug in 5 to here. How much is dz over dt? That is 1. How much is x? That's 4. How much is dx over dt? Well, dx over dt is 3 times dy over dt. So you do 3 times dy over dt plus y is equals to 3 and dy over dt. After you get up to this step, 5 equals to 12 plus 3, which is 15, times dy over dt. So dy over dt equals 1 over 3. Did the question ask you dy over dt? Not really. Dx over dt equals to 1. Because dx over dt is 3 times dy over dt, 3 times 1/3. Many students do this question wrong by choosing this, and you lose the whole question points because it's a multiple choice. They will not check your step. Okay? Last question. Now, again, this is a conic. This is conic. Actually, the conic question is not hard as long as you do the proportion. You see here, this is 16 cube feet per minute. And so you want to have the good habit writing down here. The rate of change of the water depth, dH over dt is 4 times the radius change. So dH over dt is 4 times dr over dt. Okay? So we finish this sentence. We finish this sentence. At the moment when d is 8, r is 2. So here is 8, here is 2. So we have the proportion again. Your h over your r is always 8 over 2, which is 4. So h equals to 4r. So they ask you, when h is 8, r is 2, what is the surface area changing? So surface area is pi r squared. You want to get dA over dt, doesn't matter. You want to figure out your dr over dt first. So this relative rates dv over dt will be power rule and chain rule. So you have 4 pi r squared dr over dt. You plug in 16 here, you find your dr over dt is 1 over pi. And then you want to get your dA over dt by plugging this guy over here. Okay, so number 8 is exactly the same question. We already see this question 3 times. 1 time, 2 times. Three times. Okay, So a quick summary for the relative rates question. Always it's a worst problem. When you start to read one question, you start to write down the formulas. This needs your geometry foundations. If by now you still don't know this, you shouldn't take calculus class. You want to write down this. This is step 1. Step 2, any given condition, go ahead, translate those from long sentence to simple equation. That's step 2. Step 3, use those things. Run your relative rates on both sides. Okay? And then last step, plug in all the given conditions, solve it using order 1 or elementary school math. That's all. But if you tell me, teacher, I don't know this, it's your problem for pre-cal. Go back, check your pre-cal. Okay? If you say, I don't know this, check class 3, class 4. Look for the trigonometry derivative. Okay? Go back to those old videos. That's all for today's class. Next class is the last class in this summer for calculus. We totally have 10 classes, okay? 10 classes. If you want to continue learning calculus with me when the school starts, you ask your parent to contact me to register, okay? Next class will be the last class. I will upload the video and I see you next week.